Hello everyone, my name is Bayu Anggarojati and I will be your tutor in computer networks. And today we'll be discussing about transport layers. So after we talk about the application layers, uh, we talk about different applications, protocols. We actually talk about some uh, applications requires different transport layers depending on the requirements. But we haven't talked about the more details on the transport layer protocols. So we talk about TCP and UDP, and also we talk about the socket, and then there are different sockets for TCP socket and UDP socket. Uh, so we'll be discussing more on this transport layer protocols, different between TCP, UDP, and difference between UDP socket and TCP sockets in this chapter. Okay, so this is the goal of this chapter. We are trying to understand the basic principles behind transport layer services, and there are two most important transport layer protocols called UDP and TCP, which we already know before in the application layer. Okay, so this is the roadmap. We'll talk about first. We'll try to define what the transport layer services are. We give some examples and some analogy within our daily lives, and then we talk about the multiplexing and multiplexing. So this is essentially related to the socket programming that we discussed in the application layer chapter before. Multiplexing is a process happening at the sending side, where the transport layer is combining all different messages from different processes, and then send them into the outgoing socket. Okay, and then at the receiving side, the transport layer collects all the messages from the network layer, and then delivers to different processes in that host, and this is called the multiplexing. Okay, so after that we'll start talking about the UDP, which is the connectionless transport layer. This is the most basic transport layer, so we talk about this first, and then there is a principles of reliable data transfer, but we're going to skip this because it's too complex. So basically, if you're interested, this is talking about how the development of TCP in the early development of internet at the early so basically I think this is the from the 70s and the early 80s when the TCP is first implemented in the internet. Okay, so instead we are going to jump directly to the TCP, connection oriented transport protocol. It consists of the principle reliable data transfer in TCP, and then the connection management in TCP, how the TCP establishes and close the connection. Okay, and also the flow control in TCP. And after that, we're also going to skip principles of congestion control for the same reason, because it's too complex. But instead, we are going to discuss directly on how the TCP handles the congestion in the network. There are different approaches. Actually, it's still evolving. There are different methods of congestion control in TCP, but we're going to see different examples. Some basic examples of TCP congestion control methods. And lastly, we also going to skip the last part, evolution of transport layer functionalities. Okay, so what are the transport services and protocols? So if we talk about the application layers, if we let's say separate the application from the network, so essentially it is a process running in a host. Okay, now if we add the network into in the context, so we have two processes or sub-processes running in different hosts, and they're communicating. Okay, so now the transport layer provides the logical communication between application processes in different hosts, and this is called the end-to-end logical communication. So why this is called the end-to-end logical communication? Because first, if you remember the web server communication with the web browser, for example, before the client is able to send and receive data with the HTTP protocol, it has to first establish connection, TCP connection with the server. Okay, after that, then this is called the end-to-end logical communication between the client and the server. And also later when we talk about the reliable data transfer, the sender has to make sure that the packet or segment being sent to the receiver is received correctly. Okay, but then when the sender knows that the packet is lost, it doesn't care where the packet is lost. It just knows that it has to retransmit the packet. Okay, so this is the end-to-end logical communication. And then if we talk about the how the protocol actions in the end system, at the sender side, it breaks the application messages into segments. So basically, it adds the transport layer header, either TCP or UDP, and then passes to the network layer. And at the receiving side, on the other hand, it reassembles the segments into messages. So basically, take out the transport layer header, and then passes to the application layer. And we are going to discuss two important protocols, TCP and UDP. All right, now we are trying to give the analogy between transport layer and network layers. Imagine that there are 12 kids in Ant's house sending letters to 12 kids in Bill's house. Okay, and we'll try to make analogy of hosts as houses and the processes as kids, processes in each of the house as kids, the 12 kids, and the messages of the application equals letters in the envelopes. So at the sending side, let's say the N as the sender side. Let's say if we and make the analogy N as the transport protocol at the sender, it collects all the letters from all of her kids, 12 kids, and then combine it together and then send it to the Bill's house through the postal service, which is the network layer protocol. And then the postal service delivers all the letters from N's house to Bill's house, then received by Bill's, and Bill's as the let's say the transport layer protocol at the receiving side, he will deliver all 12 letters to the corresponding his corresponding children. Okay, so this is let's say difference between the transport layer and the network layer. Now, if you look at the context of the layering in the computer networks, from the application layer messages, we add the transport layer headers. It becomes segments. Okay, and then we deliver it to the network layer, add the IP header and so on, and then pass it to the networks, received by the receiver, and that the transport layer will check the header values and then take out the headers and then deliver it to the corresponding applications via the socket. And lastly, we have two different protocols in transport layer. The TCP, or Transmission Control Protocol, it is reliable and in order delivery. So meaning that the sender has to make sure that the segment or packet being sent has to be received correctly by the receiver. And not only that, it has to make sure that, I mean, actually at the receiving side, the receiver has to, when it's reassemble the segment has to be reassembled in the correct order. Okay, so there is a sequence number mechanism. And then there's a congestion control, which we will discuss later, and flow control. These two, let's say basically the mechanism to deal with the congestion and also the flow control. This is the mechanism, so not to overwhelm the receivers with a lot of packets. And then there's connection setup, which is basically talking about the establishing and closing the communication. And then there is UDP, or User Datagram Protocol. It is a complete opposite of TCP. It is unreliable and under delivery. So basically, the sender can simply just send the packets without caring whether the packet is received correctly at the receiver or not, or it is received in the correct order. So basically, this is the most basic no frills extension of best effort IP, because basically IP protocol it is also called the connectionless protocol. And then that being said, basically there is only one guarantee in the transport layer protocol, which is the reliability, okay, in the TCP, not in UDP. But then besides that, the transport layer protocol does not guarantee delay and bandwidth, okay. Even though if we talk about the how the UDP and TCP works, UDP might be more, let's say, it is might be faster than TCP, because it doesn't have to wait for the, let's say, acknowledgement. But then still it doesn't guarantee the how much delay will be, like how much time will be spent to send a packet, and so as the bandwidth. Okay, so there is no specific bandwidth will be provided for this specific TCP connection or UDP connection. So I think that's it for the introduction of this chapter 3. We'll be talking about multiplexing and multiplexing in the next video. Okay, so see you in the next video then.